In the previous video we had a quick look at thermal power stations. We're now going to look specifically at some primary sources that are used in thermal power stations, and it'll take a couple of videos to get through this. The first one you can see will be about fossil fuels. So we're going to start off first of all by looking at gas and oil. So they're a little bit different to coal. For gas and oil, they can be burnt in a combustion chamber. So we're literally just going to supply those fuel sources into a chamber, set them on fire, and allow the transfer of thermal energy. And that combustion chamber is thermally connected to the boiler. And you'll recall from the previous video that the boiler is where the water is turned to steam, and that steam can then turn the turbine. Now for coal, it's a little bit different, and it's often crushed first. So by crushing it, it just improves the ability to combust the coal. So crushing it just improves the ability to combust the coal, and after it's been crushed, it then has to be blown into a furnace. And to help make sense of that, I'll include a diagram here. So I'll just finish that statement. So you can see in this diagram we've got this region over here that's where the coal is being supplied and then crushed into the fine powder. Once it has been crushed, it's then blown into the furnace in this section here, where it then is combusted. The thermal energy transfer then goes into the water. So the yellow section here is the flow of water and steam. So you can see the combustion occurs here, thermal energy transfer to the water, and then the water then flows through the turbine, comes back through the condenser, and continues to go through that cycle. And just a refresher again, the turbine itself is turned by the steam, which turns a generator, and then electricity will flow out to the consumer through the power grid. So there's a quick example of a coal-fired power station. The other point to note here is we've got a couple of extra bits to be aware of. So we've got the stack at the top and then ash coming out the bottom. So there's a couple of waste sources of both products and energy. So we'll talk a little bit about some of the bad things, I guess, or the disadvantages to these fossil fuels. So before we do that, it's also important to note that these types of power stations can produce significant amounts of energy. So with most of the power stations in Australia, they're generally going to be run off fossil fuels. And while they can produce significant amounts of energy, as I said, there are some disadvantages. And when we say significant amounts of power, we're usually talking up in the gigawatt range. Very common sources of energy around the world, and slowly being replaced by other sources that we'll talk about in a few videos' time. But certainly the dominant power source that we've had for quite a number of years now. So the first and most obvious disadvantage is that the sources of energy are non-renewable. So because they're a non-renewable source, it means that it's going to be hard to replace the source of coal and oil and gas, considering it takes millions of years to produce those sources, and they can usually be burnt up in only a few weeks. The second one is that, as I sort of alluded to earlier, it does release large amounts of carbon dioxide, and the reason why that's a bit of a problem is that that can impact atmospheric conditions. And what we mean by atmospheric conditions is largely can be summarized in considering the greenhouse effect and the advanced greenhouse effect. Now those two ideas we'll look at in subtopic 8.2. So we'll go through that in a bit more detail. That's largely about the transfer of energy into the Earth's environment. And so, like I say, that'll be in subtopic 8.2. The other thing to be aware of here, you might sort of think, well, CO2 is used in photosynthesis, so why is that such a big deal? The reason why it's a big deal is that the carbon that's being produced in this carbon dioxide has actually been locked in the fossil fuels for millions of years. So we're sort of upsetting the balance of carbon dioxide in the environment or in the atmosphere by releasing a lot of the carbon that's been stored for millions of years. So putting that balance a little bit out. Lastly, another thing to consider here is transportation of the fossil fuels can actually sort of lead to an overall decrease in the efficiency. Now you might sort of think, well, that doesn't really have anything to do with actually combusting the fossil fuels, but the amount of energy that we need to spend from moving the fossil fuels from where they're mined to power stations means that we're using up some energy that would otherwise could be used for consumers. So in considering a Sankey diagram here, you might sort of indicate that there is some of those transportation losses. So the input loss that you get is some of it is results from the need to transport fuel sources from their place where they're mined to where they're being used in power stations. Now that can be minimised somewhat by making sure that the power station is as close as possible to the fuel source, but considering the remoteness of some of the coal mines in places where gas and oil are mined, that can be difficult in some situations, so it's not always possible. In the next video we'll start looking at nuclear fuel, and then we'll continue on after that.